Class 12, let us continue the chapter. This is the last sum for this exercise. Last sum means last sum for 5 marks questions. Okay. Other sums I think now you can do on your own. You have to try. Now if A equals to, all 5 mark sums are really very big sums. You have to practice daily. Otherwise you cannot solve it. Means your problem will come, you cannot solve the problem. 0 minus tan alpha by 2, tan alpha by 2, 0. And I is the identity matrix of order 2. And this is given. I is the identity matrix of order 2. Okay. Now what we have to show? We have to show that I plus A is equal to I minus A into cos alpha, sin alpha, minus sin alpha, sin alpha, cos alpha. Cos alpha minus sin alpha, cos alpha. This we have to prove. Okay. Now the solution. So let us, since I plus A is there in the left hand side, so at first let us find I plus A. Okay. So what is I plus A? I plus A is what? I means since I is the identity matrix of order 2, so I we should write at 1 0 0 1. 0 0 1. Okay. Plus A is what? This 0 minus tan alpha by 2, tan alpha by 2, 0. Okay. Add these two. Corresponding elements will be added. It's very simple. So it is coming 1 and this is minus tan alpha by 2 and this is tan alpha by 2 and this is only 1. Okay. Now I minus A. Now find out, since right hand side is there only I minus A. So let us find I minus A also. So I minus A means 1 0 0 1 minus 0 minus tan alpha by 2, tan alpha by 2, 0. Okay. So 1 minus 0 is 1 and 0 minus plus. It is coming 1 tan alpha by 2 and minus tan alpha by 2, minus tan alpha by 2, 1. Okay. Now I minus A inverse is how much? I minus A is this. So I minus A to the power minus 1. Inverse term will be what? Therefore, I minus A to the power minus 1, it will be 1 minus tan alpha by 2 and tan alpha by 2, 1. Okay, this is I minus A inverse. And just expand this one. Always we expand means determinant not yet done, but just try to understand if the elements are written in this way. If you want to get the only the expansion part, only the expansion, then how to write the expansion part? This we will follow this direction. That means this corner, this element, we will start from left corner. So 1 into 1 like this minus left upper left corner into right lower corner minus lower left corner into upper right corner. And direction is this, and where we will write minus. This is the expansion rule. Okay, here we will follow this. So 1 into 1 is what? 1 into 1. We will write the only the expanded form. So 1 into 1 is 1. Minus sign is there. Then tan alpha by 2 into minus tan alpha by 2. Minus minus, it will be plus. So tan square alpha by 2. It is coming tan square alpha by 2. Understood everyone? This is the expansion rule. When we will do the determinant form, that time it will be clear to you. This is the expansion rule. So 1 plus tan square alpha by 2. 1 plus tan square alpha by 2. 1 plus tan square alpha by 2 is this. So 1 plus tan square theta is equal to sec square theta, we know. So this here we can write, this is as sec square alpha by 2. This is as sec square alpha by 2. Okay, now let me rub this part first. Okay, so this is sec square alpha by 2 already written. Now, I minus a whole to the power inverse means I minus, this is also sec square alpha by 2. 1 into 1 minus tan alpha by 2 into tan alpha by 2. So this term is also tan 1 plus tan square alpha by 2. Directly we can write sec square alpha by 2. Okay, so we can write therefore I minus a is also is equal to sec square alpha by 2. Okay, therefore I minus a whole inverse is equal to 1 by cos square sec square alpha by 2, 1 by sec square alpha by 2, 1 by sec square alpha by 2, that is equal to cos square alpha by 2. That is equals to cos square alpha by 2. Okay, and yes, that is equal to I minus 8 is written already, 1 minus tan alpha by 2, and this is tan alpha by 2, 1. This we can write. Okay, therefore I plus a into I minus a whole inverse means 1 by I minus a is equal to, we can write this is equal to cos square alpha by 2 into 1 minus tan alpha by 2, here tan alpha by 2, here 1 into 1 minus tan alpha by 2, tan alpha by 2, and then 1. Okay, now we will multiply this. So it is coming cos square alpha by 2, and first row first column, we will get 1 minus tan square alpha by 2. 1 minus tan square alpha by 2. And here it is minus 2 tan alpha by 2. And this side 2 tan alpha by 2. And here also 1 minus tan square alpha by 2. Now 1 minus tan square alpha by 2, that is equals to, we know that and the outside it is written cos square alpha by 2. So we can write this calculation part left. 1 minus tan square theta, tan square alpha by 2. Just do this calculation. What we will get here, we will get cos alpha. Here we will get minus, since minus 2 tan alpha by 2. So 2 sin alpha by 2 by cos alpha by 2 into cos square alpha by 2. So 1 cos alpha by 2 will be cancelled, and we will get minus sine alpha by 2. Minus sine alpha. Alpha by 2, sine alpha by 2, cos alpha by 2. That means only sine 2 alpha by 2. That is only sine alpha. So it is coming minus sine alpha. Okay. Now next is sine alpha. The same calculation. Here also cos alpha. Okay. Here also cos alpha. Therefore, I plus a is equal. This is 1 I minus a whole to the power minus 1. Therefore, 1 by whole to the power I minus a whole to the power minus 1 means 1 by I minus a. So we can write here I minus a into this cos alpha minus sin alpha cos alpha. Understood? Yes, this is proved. This only we have to write. Yeah, same thing right here, then it will be easier. I plus a whole to the power I minus a means right here I minus a. Okay, therefore I plus a means I minus a into this. Okay, now all sums, most of the sums, 80% sums done, 5 marks questions, only few sums were left. That also made video. Now this chapter is completed. Next online class or next online class I will start, already have said I will start your indefinite integral. Okay, now few videos you will get on second order derivative. Okay, bye.